We are on Chapter 5, Section 3, Proving Triangles Congruent by SAS. If you're not sure what that means, it means side, angle, side. So last lesson we proved that triangles are congruent by stating all three sides and all three angles. For this lesson, side, angle, side, you only need a side, the included angle, and the side to be congruent. So what does included mean? What are included sides and included angles? Looking at this slide, included sides. The side between the given angles. So I'm going to show you an example on what those mean. So looking at this diagram, example is side A, segment AB, right here in pink. Let me use a highlighter. Segment AB is included between angles A and angles B. So I'm drawing it on the diagram. What does this word mean, included? If you have a segment that is included, it just means the side between the two angles. Okay, the side between the two angles. Can we all see that? It's a little difficult to see. Let me see if I can use a little different color. It's the side between the two angles. Okay, so it's the side, segment AB, that's in between my two angles. Keep in mind if it was somewhere else, if the side was, let's say, right here, that would not be considered the included side. It has to be the side in between the two angles. So now looking at the next one, it says the included angle. What is my included angle? Let me get a different color. So included angle is the angle where the given side meets. Okay, so here I have my sides. So looking at it, this is the angle we're talking about. Angle C is in between segment A and B. Again, what does it mean to be the included angle? It's an angle between two sides. It's the angle between two sides. You could also think of it as the two sides that make the angle. Okay, so those two sides are going to make angle C when they meet. So that's the included angle. All right, side, angle, side congruency theorem. This is a theorem. Yes, you can use it to prove triangles are congruent. It says, if two sides and the included angle of one triangle are congruent to the two sides and the included angle of the other triangle, then the triangles are congruent. So I'm going to go ahead and draw it as a diagram just so you can get an understanding of what these words are saying. So here is my triangle. If I had a congruency statement as triangle ABE is congruent to triangle DBC, let me go ahead and label it. I have A, B, C, D, and E. In order for it to be side, angle, side, pay attention to how I'm proving this. What angles are going to be congruent? My vertical angles. So this angle, let me get a lighter blue, is going to be congruent to this angle because they're vertical. My sides, keep in mind that is considered my included angle because I'm using that A. So my sides are going to have to be this side, AB, is going to be congruent to BD. Okay, here's AB, DB, or BD. And then EB is going to have to be congruent to BC. That's where I'm getting my congruency from. And then the angles that were congruent are going to be the ones that are vertical. Keep in mind for this, always, order matters. Your order always matters. So make sure when you're writing your congruency statements or you're drawing your congruency marks that the order matters. You have to make sure you're writing it accurately or it's going to get mixed up or confused. So again, looking at it, here is my side. Here is my included angle and my other side that's congruent. Same thing, here is my side. Here is my congruent angle and my other side that is also congruent. Example number 1 says, state which congruence method or methods can be used to prove that the triangles are congruent. If none, state NC. Remember, we're trying to find side, angle, side. So looking at A, we stated this last class. If they are sharing a side, then that side is going to be congruent. So looking at this diagram, this side is being shared. So I'm going to go ahead and mark my congruency marks. Other than that, I cannot add anything. I cannot add any marks unless it's given to me or it's told. So looking at this, would this be considered a side, angle, side triangle? No. Okay, this would be no. Let's just double check. Here is my side that's congruent. Here is my other side. This is not my included angle. Okay, so this angle right here, as well as on the other side, is not my included angle. If you were to name this as a congruent triangle and you were to say this is angle side side, that would be no. There is no angle side side as a congruency statement. So you cannot say it's an angle side side triangle. Looking at B, would this be considered an angle side side triangle? Yes. Okay, keep in mind they're sharing this side right here. So I'm going to go ahead and mark my congruency marks. I have a side right here, my included angle and another side, a side, my included angle and another side. So for B, this is going to be a yes. And do not forget to mark the reflexive side. Okay? So please understand the difference between reflexive and symmetric. If they are sharing a side, it's reflexive. So they are sharing a side. So if I were to give you variables like A, B, C, and D, this would be written as BD is congruent to, if they switched these, it's still reflexive. Okay, this is still reflexive, it is not symmetric. So just understand that this is still a reflexive congruency. All right, let's go ahead and go to C. Is there anything here that's congruent that we know automatically? What would be congruent? Yes. Okay, so yes, they're giving us those. But what would be congruent that they're not giving us the symbols for? Yeah. The vertical angles. So I already know that my vertical angles are going to be congruent. Keep in mind I'm using 3 congruency marks. Why? Because they already gave me one with 1 and they already gave me one with 2. These are not congruent. How do I know? This one has 1 mark. This one has 2. They are not congruent. Would this be considered a congruency statement using side, angle, side? Yes or no? No. Okay, good. There's no other side. There's no other side to prove it as side, angle, side. You cannot add your own marks. The only ones you can add are vertical angles or if they share a side. You cannot add anything else. So you cannot go and say, oh, but these look like they're congruent. you cannot add those. The only thing you could add are your vertical angles because we know they're going to be congruent. Or if they share a side, like looking at D. If they're sharing a side, I can go ahead and mark that they're congruent. Would this be congruent using side angle side? Okay, I have my side here and my side that's congruent. This is my included angle, so this would be a yes. This question is very similar. It's the same, almost the same as B. Okay, so again, don't forget to mark that reflexive side. And then looking at E, is this considered congruent using side angle side? This would be no. There are no sides here. So let me rewrite that. Looking at this one, this would be, if you were to call this something, you may say it's angle, 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 but just understand there is no angle, angle, angle. Okay, yes, all my angles are labeled. It is not angle, angle, angle. Why can it not be angle, angle, angle? Because keep in mind, congruent means same size and same shape. If I made this image larger, yes, my angles will stay the same, but my side measurements will not be the same. So it cannot be angle, angle, angle. All right, example number 2, it says, is there enough given information to prove that the triangles are congruent? If there is, state the postulate. So I'm going to go ahead and highlight which triangles we're talking about. They're giving me A, B, E. So this is one triangle. And then they're asking, is it congruent to CBD? So there is some sort of overlap here. Where is my overlap? It's the one in the middle. So even though the colors are not really overlapping, I'll just highlight it in yellow. I'm going to go ahead and draw the two triangles. I have this triangle right here. This is A, B, E. And then I have C, B, D. So a couple things I have in my triangles that I can mark. I have two congruency marks over here for A and B. And then I know that B and E are going to have one congruency mark. And looking at my next triangle, I have 2 marks on BC and 1 mark on BD. I need to figure out, is that angle at the top congruent? I'm going to zoom in and kind of explain how I know. These two have the congruency marks already, so we already know they're congruent. So I'm just going to throw out some measurements there just for you guys to think about. If I said that this is 7 degrees, this is also 7 degrees. This angle looks like it's by itself, so we're just going to call this 20 degrees. However, your green triangle, your peak of your green triangle is this entire thing. The overlap is going to be congruent. Okay, your overlap is going to be congruent. So what would the entire peak of my green triangle equal? What would it equal if I were to add them? It would be 27 degrees, right? Looking at my pink triangle, this is my entire peak of my pink triangle. What would that equal? Good, 27 as well. So would the peaks of the triangles be congruent? Yes, you guys need to understand that when you have something that's overlapping, it's going to be the same for both. So looking at these two triangles, these peaks are both congruent. And yes, this is going to be considered a side angle side triangle using side angle side congruency theorem. So just showing you where everything is. This is one side. That's congruent. This is my angle. That's congruent. And this is my leftover side. That's congruent. So yes, the included angle is in between my sides, so it is considered a side angle side triangle. All right, example number 3, it says state a third congruence. You would need to prove that the triangles are congruent by side, angle, side. So I need to prove they're congruent using side, angle, side. So I'm just going to write it here. Side, angle, side. What are they giving me? I'm going to go ahead and highlight what they're giving me and what I have to be able to find. So first they're telling me ST is congruent to YZ. So I'm going to go ahead and mark ST right here is congruent to YZ. That's my first side. Okay, and now they're giving me a second side. RS is congruent to XY. RS is congruent to XY. What am I missing? I'm missing my angle, right? Where would that angle be that would make the statement congruent? Which angle would it be? Which angle? I can't say it one more time. RT would not be an angle. RT is considered a side. T and what? Let's think about it. T and what? Okay, if I'm marking it here, I'm just going to use red. Would this be considered my included angle? T and Z. Is that considered my included angle? Let's look at it. I have side, side, angle, or angle, side, side. I cannot have angle, side, side. That is not a congruency. So T and Z could not work. So T and Z could not work. What would my included angle be?
So where would go side and the side?
Okay, but what would the included angle be? S and what?
Y.
S and Y would have to be my included angle. So in order for this to be proven side, angle, side, I would need angle S to be congruent to angle Y. You guys have to understand what the included angle is and where it would go. All right, last slide is a proof. These ones are not difficult. Okay, again, like I said last class, draw what you have, draw what you're finding. So I'm going to go ahead and start out with my T-chart. I have my statements, my reasons, and I'm going to go ahead and start out what they're giving me. The first one is going to be given, so I'm going to go ahead and write my given first. Ooh, is that too dark? Yeah. BC is congruent to DA. And BC is parallel to AD. And that's given. Is it drawn on my diagram for me? Yes, it is. Okay, so just showing you, here's my congruency marks, here is my parallel symbols. They want me to prove that triangle ABC is congruent to triangle CDA. So, looking at the diagram, what do I know that is not shown for me? What do I know is going to be congruent? Can anybody tell me? Yes.
CA is going to be congruent.
Good. CA is congruent to itself. So I'm going to go ahead and write that one down first. So I'm going to go ahead and write my second one. Let me get a brighter blue. CA is congruent to CA or AC. Doesn't matter how you write it. What would this be considered? Remember, it has to be a theorem, a definition, a postulate. What would I write for this? If I'm stating that CA, it's not symmetric. It's reflexive. Don't get those mixed up, okay? Keep in mind, even though I switched the letters, it's still the exact same thing. So it's not symmetric. If they're sharing a side, Whenever you see they're sharing a side, it's always going to be reflexive. So this is reflexive property of equality. I'm just going to go ahead and write congruence. We'll just write congruent. Oh, because they're congruent triangles. So we'll write reflexive property of congruency. All right, now that we know that, remember, we can prove it using side, angle, side. So what would my angle be? Where would that angle be? I have my two sides. Where is my included angle? And how do I know that they're congruent? Yes. Camilla? You want to do it? Okay, if I made B and D, are those considered my included angles on my sides? No. So let me go ahead and highlight my sides. This is a side right here, which is congruent to this side. And this is my other side. Where would my angle then go? Where would it go? C and A, but there are technically 1, 2, 3 angles of C and 3 angles of A, so you cannot name it C and A. What's the proper way for me to name that angle? Say it one more time. How would I name that angle? BCA would be right here, and then what's the other one? Okay, if I'm going from side 1 to side 2, I have to follow the same pattern. So BCA, and then what would the other one be? DAC. So what do I know about these two? That they're going to be congruent. How do I know that these are going to be congruent? So angle D, what did we say? BCA? BCA is congruent to angle DAC. So how do I know that those two angles are congruent? Let me write it so you can see it better. Angle BCA is congruent to angle DAC. How do I know that they're congruent? Yes, Laura? Good. They're alternate interior angles theorem. How do I know they're alternate interior angles theorem? So looking at my diagram, I know I have two parallel lines right here. Here's one. Here's two. That's what I highlighted in red. They're parallel lines. Those parallel lines are then cut by a transversal, which is A and C, which then makes those angles alternate interior. So because now I found my side, angle side, I'm going to go ahead and state what I have last. I just proved, so step 4, triangle ABC is congruent to triangle CDA because side, angle, side, congruency theorem. And I'm done. That would be my reasoning for it. I have side, angle, side, and I'm finished. I don't have to name all the angles. I don't have to name all the sides, because when you do have a side, angle, side triangle and they're congruent to each other, it is going to be a congruent triangle. All right, you guys have homework on big ideas. You do not have to show work. You only have to write out proofs 8 and 9.